All right, a particle starts at the origin and moves along the y-axis so that its position is given by y of t is equal to t squared minus 6 square root of t for t going from 0 to 9 seconds. So the first thing we want to do is find out where the particle is after 2, 5, and 9 seconds. So all that means is really to let t equal 2 and plug it into the position function. So we'll have 2 squared minus 6 square root of 2, which is 4 minus 6 root 2. Or if you want to go to decimals, we got negative 4.485. When the time is 5 seconds, all we have to do is plug in 5. So 5 squared minus 6 square root of 5 is 25 minus 6 root 5. And on the calculator, we're looking at 11.583. And then finally, at 9 seconds, we're just going to take 9 and plug that one in. So y of 9 is 9 squared minus 6 square root 9, or 81 minus 6 times 3, which will give us 63. So real quickly, what we notice is that the particle is starting at the origin, and then initially it goes down to a negative number, and then somewhere it turns around and continues to go positively. Next, we're asked to find the particle's velocity function. And the thing to remember is that velocity is the derivative of position. So I'm going to take that position function and just find its derivative. Derivative of t squared is 2t, and the derivative of square root would be 1/2 t to the negative 1/2. So 3 over the square root of t. So far we have two functions now. The first one is the position function, so where the particle is on the y-axis, and the second one is our velocity function, so how fast it's moving at any given point in time. In part C, it's asking when does the particle stop? Well, if something is stopped, its velocity is equal to 0. So I'm going to take my velocity function, 2t minus 3 over the square root of t, and set that equal to 0 and solve it. So first thing, I'll multiply both sides by the square root of t, and that will get rid of my denominator. So multiplying by square root of t, I got 2t times square root of t, that'd be 2t to the 3/2 minus just 3 is equal to 0. So I'll get the t alone by adding 3 and dividing by 2, and I'll finish this up by taking both sides to the power of 2/3. That'll give me t to the first power. When we take that to the calculator, we'll have that t is equal to 1/2 to the 2/3 power, which as a decimal is equal to 1.310. And of course that is a t, so that's time, 1.310 seconds. That's important in the next part, because the next part asks us where does it stop. So the difference between when it stops and where it stops is that where is asking for a position. I know when it stops at 1.3 seconds, so I'm going to take that and plug it into my position function. So I'm just going to take that 1.310 and square it, minus 6 times the square root of 1.310. And I'm going to definitely take that all to the calculator, and we'll get negative 5.151. All right, so putting all this together, we just saw that the particle started at the origin, went down, and went back up. So the particle started at the origin and went down to negative 5.151. where it stopped and turned around and went up for the rest of the 9 seconds. And we saw in the first part that its position after 9 seconds was at 63. So the real question is, how far did this thing travel? It didn't travel 63 units. It started at the origin and it ended at 63, but it traveled a little bit more than that. So the first thing is that it went down to negative 5.151. So if we're thinking about the total number of units that it's traveled, so far it traveled 5.151 units. After that, it turned around and went up to 63, which means that from that negative 5.151, it had to get back to the origin, which took 5.151 units, and then continue on to 63. Now, if we go ahead and add all that stuff up, we end up with 73.302. So thus, it traveled a total of 73.302 units.